Hello guys, welcome back to our video series of system modeling and simulation. We are going to continue with types of simulation model. Type of simulation model. Now we have two main types. We have deterministic model and stochastic model. Deterministic model and stochastic model. Now, stochastic model can be either static or dynamic. Just like you can see here, stochastic and static model are also called Monte Carlo model. Monte Carlo. So a Monte Carlo simulation is a stochastic static, model. Now, dynamic simulation can either be continuous or discrete. Continuous or discrete. So let's try to understand what all this means. Now, let's try to compare stochastic and deterministic. Stochastic simulation. A simulation that contains random element, probabilistic element, are said to be stochastic. So when probability is high, when the probability is high, when chance plays a high role, For example of stochastic event, inter-arrival time or service time of customers at a restaurant or store, amount of time required to service a customer. So here the output is a random quantity. So the output is a random quantity. So it is not something you can you can really quantify exactly. So it is randomly. So inter-arrival time or service time of customers at a restaurant. So sometimes you go to a restaurant, for example, and sometimes it takes longer, and sometimes it takes shorter. When does it take long? It takes longer because the queue might be long. They are cooking other plates for people who came before you. You see, people who came. If you find that many people came before you, so that waiting time will be longer. And this one you cannot exactly calculate it. So sometimes you'll have the chance of finding that there are not many in front of you. Then you will be served faster. But other time you are going to find a very long queue. So we are going to wait for 1 hour plus. So there's a factor of chance, there's a probability, there's a probability to find a long queue or a probability of not finding a long queue. So this is probabilistic. It is, it is not something you can quantify exactly to say that I'm going if you are the owner of a restaurant, you are going to serve a plate every 5 minutes. You can't do that because you don't see what's going to happen. They might just decide, like this COVID. With this COVID, you see the rate of serving has declined, and you could not imagine that COVID will come. So if you were serving 100 plates per day, this will move to 10 plates, delivery service, home service, just because that, you did not have chance that this continues. Something has occurred and which hindered, which affected your business. So you cannot easily quantify. So it is what makes stochastic simulation very complex. Very complex because they are not exact. You cannot predict and say that I will be having a client every 5 minutes, or I will be having a client every 10 minutes. You see that? So it is why stochastic simulation, are very complex. Now, what about deterministic simulation? A simulation containing no random element. Simulation of a digital circuit. Simulation of a chemical reaction based on differential equation. Output is deterministic for a given set of in. Here, guys, what is the probability? What is the probability of your experiment not being successful? If you have the circuit in front of you, you just simulate it. So there are no factors that can really affect your simulation. But with stochastic simulation, there are many factors which can affect. They can close due to COVID. They can close your restaurant due to COVID. Or that day, client, the chance that client don't come, to your restaurant just like yesterday. So you receive today 100, tomorrow you receive 50. So there's a chance involved. But here with deterministic simulation, chance is not involved, probability is not involved. So it is why deterministic simulation are the simplest simulation. They are simplest. Why? They are simplest because they don't engage too much chance. There's no probability. Chance does not affect deterministic simulation. So we have seen the types of the applications, and we have seen that we have low level abstraction, and then medium level abstraction, and then high level abstraction. Yeah, so look at what you have here, the base, like control system, computer hardware, battlefield, traffic. These really they are more manufacturing. These are more engineering. These are more engineering. Though some are stochastic, but they don't involve too much probability. But control system and hardware, for example, there's no chance really affecting this, and is why they are most of the time they're deterministic. So but up there where we have social system, economic system, market system, my dear friend, there's a lot of chance in. So most of them are stochastic. Now, static versus dynamic. When do we say that a model is static and dynamic? You have seen that a stochastic can be static or dynamic. Even a deterministic can be static and dynamic. Now, a static model is a model where time is not a significant variable. Time, you don't care about time. It can take the time it takes. You don't care. For example, to determine the probability of winning a solitaire hand, statistical sampling to develop approximate solution to numerical problem. So here you don't mind about the time. So a model where you don't mind about the time is a static. Now we say that a static plus stochastic simulation, which are static, are Monte Carlo simulation. Now dynamic model are model where model focusing on the evolution of the system under investigation over time. Here time is very important. Time is very important in dynamic model. Now, continuous versus discrete. What are discrete model? The state of the system is viewed as changing at discrete point in time. An event is associated with each state transition. Event contain timestamp. Now, what is discrete? Generally, what's the difference between discrete and continuous? Something is discrete when it can take values which are known, known values, and generally these values they are not many. For example, when they say discrete math, why do they call it discrete math? Because it only deals with two values, 0 and 1, true or false. For example, gender is a discrete variable. It's discrete because it can only take two values, can only be either female or male. There are only two. As of now, I have not heard about the third one. Even if you change your gender, you are still good. Continuous then. Continuous can take different many values, like a name. You see, a name, for example, if you have the entity student, a name of a student, is something continuous, can take up many values. The state of the system is viewed as changing continuously across time. It's non-stop. System typically described by a set of differential equation. Continuous simulation are non-stop. Values of variable keep changing. But in discrete model, the system, we are just interested to see changes at discrete point. So it is why in most business simulation are discrete, because you see, like the simulation I ran. The simulation I ran, the first in the second video, that one is an example of discrete simulation. Why? Because you have your plant, you have your factory, and you are just interested to see changes at different points. For example, the factory is running. Now you see, after one day, a milestone is a day. After one day, how many units have you produced? After 1 week, how many units have you produced? After 3 months, after 1 month, after 1 year, you see that, you just observe the changes of the system at discrete point in time. So you are not interested to monitor the system continuously. Now, when every time comes, then your simulation is continuous. But when only discrete times come, your simulation is, this discrete. Now, how do you develop the development life cycle? How do you develop a model in simulation? It's quite similar to what you know in software engineering, system development life cycle. So it's quite, it looks like kind of waterfall, waterfall that you guys put in all your books. I don't know who told you guys that only waterfall exists. Now, you define goals. The first step is you have 6 steps. You define goals of the study. You develop conceptual model. You develop specification. You develop computational model. You verify your model, and then you validate your model. So let's see what we get here. Define goals and objective of the study. These steps answer the question: what does you this crazy English, what do you hope to accomplish with this model? Oh, this guy, in fact, I submitted 2 versions of the book, and they just printed the former version. That was terrible. So you find many mistakes. They did not consider the right version. That was super, annoying. Now, what do you want to study? It might be to predict the weather, to train personnel to develop a certain skill like driving, like piloting. You see? So what do you want? So you need to know what you want. And then develop conceptual model. These steps involves creating an abstract representation of the model. Conceptual, something conceptual is something abstract, something fuzzy. What should be included in the model? What can be left out? What abstraction should be used? What metrics will be produced by the model? Appropriate choice depend on the purpose of the model. Develop specification means moving more into the details. So detailed specification of the model are developed. Collect data to populate the model. Development of algorithm necessary to include in the model. And then computational model. At this stage, the model is implemented in the system. Computational. Executable simulation model, software approach, general purpose programming language, special purpose simulation. All these steps. So here you implement the model, and then you verify. Did I build the model right? Does the computational model match the specification model? Largely a software engineering activity. Not to be confused with correctness. Verify and validate are very different. Verify is like testing. Now validate means, validate means to make sure that it matches the specification. Just like in software engineering, testing and validation are totally different. So in software engineering, when you test, you make sure that your system is correct, that there are no errors, you know. And but when you validate, it means that here you are validating the acceptance, and generally it is done in presence of the client, the product owner. So the product owner will come and validate whether what you have developed, matches their expectation. So you validate. Does a computational model match the actual system? Measurement of actual system, analytical model, analysis. So here in brief, you validate whether the what is developed matches the specification. So what are the modeling and simulation method? So we say that we are going to cover three methods of simulation. We are going to cover system dynamics, discrete event modeling, and then agent-based modeling. In modeling and simulation, a method is a framework we use to map a real-world system to its model. You can think of a method as a type of language or a sort of term and condition for model building. There are many methods used to model and simulate systems. The modern ones we have chosen for these are the following: system dynamics, discrete event simulation, and agent-based modeling. So we are going to cover these three modeling methods. Now let's try to see here. Look at this. So we have seen the different application areas of modeling and simulation. Now here we are trying to advise, we are trying to advise which method to use in which situation. You see on top here, when a system is very complex, like a social system, like a market system, economics, human resource, this system made of very huge dynamics. So then the method you use is the method which is advised is system dynamics. So system dynamics is meant for high abstract model. Now AB, agent based, can be used for low and medium, but you can also use it for not very high abstraction, not very high abstraction, like human resource, is high, is really high, but not like a social system, when it comes to understanding the whole social system and behaviors, AB. Now for not very high abstraction, like business processes, transportation, and all these, you can use discrete event modeling. So now it's going to tell you which method you use, but it's up to you to understand, the level of abstraction and then decide. But even business and engineering, you are more likely to use in business. In business, you are more likely to use discrete event because we are interested to know, discrete because we are interested to know changes in the system at, given interval. If you are a clinic, for example, so you are more interested to know how many patients you can receive in a day, in a week, how many resources you need, stuff like that. Now, agent-based, apply in engineering, apply in business as well. AB has a large as compared to RACE. AB has a large range of application, agent-based modeling, from industrial processes to business processes, even to social processes. But when it is too complex, so when it's social, highly behavioral, then you use system dynamics. Now you guys, now what happens in your head as a model? What happens in your head as a model? These three methods use different approaches. Agent-based will use different agents. Discrete event will use generally a flowchart to try to depict the process, and system dynamics is going to use stocks and flows. So we are going to study all these ways of representation. So when we are going to do system dynamics, we are going to use stock and flow diagram. When we are going to do discrete event modeling, we are going to use flow charts. And then when we are going to learn agent-based modeling, we are going to try to understand the different type of agent and how they can behave. So here in agent-based, we don't really have diagramming really. We don't have serious diagramming involved. But here we use flowchart, and here we use very huge diagramming, and which is new to you, this one, system dynamics. So the only thing that will be new to you are stock and flow diagram. But for flowchart, you use a flowchart. You know how to do a flowchart. You have seen how to do that in. Now the lab one is installing. You have to install AnyLogic. You have to install AnyLogic and perform these. You see, it shows you step by step. You have to click. It is a walkthrough. It's a walkthrough. Click here. So I don't need to be there. I never do that. So I always give you shows you step by step. Here we have a unit summary, so you can read. And then I have some questions here. I'll pick a few there for the exam. And then we move to Unit 2, Agent-based modeling and simulation. So guys, we are going to cover these in the following video. So I would like once again to thank you for watching, and see you in the next video. Bye bye.